Okay, in this video I want to talk about factoring what are called sums and differences of perfect cubes. Okay, so our goal here is to factor sums and differences of perfect cubes. Okay, so before we get going too far, let's just look at a couple of quick examples. What do I mean by sum of perfect cubes? Sum of perfect cubes might be something like the expression 8x cubed plus 125. Okay. This is what we would call a sum of perfect cubes. Here it takes a little bit of an eye to see that we've got two numbers being cubed. What is being cubed? Stop and think for just a moment. What's being cubed on the left here? Okay. The answer is not 8, it's not x. The answer is 2x is a number that's getting cubed. And notice that if I were to simplify 2x to the third power, I'd end up with 8x cubed. That takes a little bit of an eye and a little bit of practice, that the base here, the number that's being cubed, is 2x. Okay. And over here we've got plus a number cubed. Again, in this case, it's the number 5 cubed. Okay. Looking at one more example, let's look at a difference of perfect cubes. Let's look at, say, x to the third minus 1. Sometimes with the number 1, it's hard to identify. 1 is a perfect cube. It's itself cubed. So this could be rewritten, if I wanted to see it as perfect cubes, it's the number x being cubed minus the number 1 being cubed, and that takes a little bit of practice to see. So let's look at the formulas for the sums and differences of perfect cubes, and these are two formulas that you should memorize. Formulas. Okay. The first formula is, if I have a sum of perfect cubes, if I have something that can be written in this form, a to the third power plus b to the third power. This is a sum of perfect cubes. It will factor this way. Now, perfect cubes will always factor into two components. The first component will be a binomial component, and the second component will be a trinomial component. This will factor to be a plus b. Notice that the first part, the binomial, looks very similar to the structure of the original, just without the cubes. And for the trinomial part, we've got a squared minus ab plus b squared. Okay, let's clean that up just a little bit. Okay, so this is the formula that if you're giving an expression in expanded form. Okay, this expression is written as a sum of things, and you want to rewrite it in factored form, that is, as a product of entities, a product of factors. Then it'll factor this way. A to the third power plus b to the third power factors to be this binomial, a plus b, times this trinomial. Okay. For the difference of perfect cubes, we've got a very similar formula. And there's no coincidence there. We've got a very similar formula. And in this case, the formula looks like this. The binomial component, just like before, the binomial part looks very similar to the original. A minus b, it follows that structure. Okay. And then for the trinomial part, again, it's very similar. What will be different here is the sign of that middle term. And for the difference of perfect cubes, this ends up being an addition sign. Okay. So you'll need to memorize these two formulas, and they'll be useful. What I'd like to do now is look at an example of factoring a difference of perfect cubes. If this is for the 136 class for the factoring worksheet, this corresponds to question number 3 letter P, or excuse me, letter O first. So the directions here are to factor, and we've got x cubed minus 8. So first of all, we need to recognize, if we're being asked to factor this, we need to recognize that this is a difference of perfect cubes. So let's take a step to rewrite it so we can see it as such. This factors to be x cubed minus 2 cubed. Okay. Down below is what I'm going to do is I'm going to go ahead and put our formula. You don't need to write this each time, but I think it's useful until you get some practice. We see then that we have a cubed minus b cubed. So after we've written this, here we can simply identify what a and b are. So in this particular problem, x cubed minus 8, a is being played by x. And in this case, b is being played by not 8. Right? Notice that b is not 8. b is the number that's being cubed. In this case, b would be 2. Okay? And because of this, and we know that we've memorized the formula, this factors to be a minus b times a squared plus ab plus b squared. We'll simply follow the structure of the formula, and in this case then, this will factor to be x minus 2 times the quantity x is squared plus, I'm going to write it, I'm going to go ahead and simplify it, but it would be x for a times 2, okay, so or 2x plus 2 squared, which is 4. For this next example, we're going to factor 8x cubed plus 125y cubed. Okay. So again, we need to first identify this as a sum of perfect cubes, and in this case, I think this one's a little bit more difficult than the last example to identify the components that are being cubed. In this case, a is what? What is the number that's getting cubed? What number here on the left is being cubed? It would be 2x. Okay. And in this case, b is what? In this case, b is 5y. So in factoring this sum of perfect cubes, let's rewrite it as 2x cubed plus 5y cubed. Okay. Down below, I'm going to rewrite the formula for the sum of perfect cubes. The formula for the sum of perfect cubes is a cubed plus b cubed. Well, that factors to be, remember, it factors to be a binomial and a trinomial. The binomial part looks very similar to the original without the cubes, and the trinomial part is a squared, watch the sign, minus ab plus b squared. Okay. So let's go ahead and factor this. Okay. The formula says we take a plus b, and we've identified a to be plus b, which is 5y. Okay. That's the a plus b part. Times, and now here I'm going to write it. I'm going to write out all the parts of this. A will be 2x, and that gets squared, minus, what is a? It's again 2x, times b, which is 5y. And if you wanted to simplify this all at once, you could, but I'll take a second line to do that, plus b squared, and again I'm going to write that as 5y squared. Okay, so there's my binomial part, and here's my trinomial part. Rewriting this gives me 2x plus 5y times the quantity 4x squared minus 10xy plus 25y squared. So we've factored the original statement written in expanded form. We've now written it in factored form, and here's our solution.